Okay, so this activity will make you understand the decay reaction, how to write the products and reactants. Okay, so it's very easy. So what we are going to do, first you are going to write the symbol for that alpha particle. Either you can use helium-24 or alpha, it's up to you. Use one of this, whatever is comfortable. Or for beta particle, you can write -1 is 0 or beta -1 is 0. Use one consistently, so that will help you. Okay, and you have a Ziploc bag with the 3 type of card. Sort them into 3 groups. Okay, so starting element, they are all in one color. Each class will have a different color, so I'm not saying the colors. Starting element in one color, and product cards, which has product cards with the letter on their upper left hand corner. Sort them into different. Then also you will have particles, that is alpha beta particles, alpha beta gamma particle. There is only 3 cards. Okay, so first go ahead and find the starting element, which is this. So you are going to write the starting element on this, and on your sheet there is a sheet given there. You are going to place the alpha particles. So get the 4 alpha particle. So what is that? Okay, then it is removing, so 90 minus 2 will be what? 88, and 234 minus 230 minus 4 will be 226. So now look for the, use your periodic table to identify that element and look for the product card. Product card is will have a letter. You are going to write that letter here. So same thing, again take another, again use the same, then just change the particle into -E1 0 and write the product. Okay, and then find that card and write the symbol there. Okay, continue, it is very easy. So topic 4, we are going to talk about the nuclear stability. Okay, so nuclear stability, what is nuclear stability? So we know that nucleus is a very small region which packed lot of positive protons and neutral neutrons. Okay, there is a nuclear force is existing between these nucleons. Okay, at the same time there is repulsion between positive proton. We know that positive, same charges always repel. Okay, so the nuclear force value must be greater than the repulsion to get stability. Okay, let me see. So what are the conditions which causes the nuclear stability? Okay, the first condition, we can say the right ratio of N by P. Too many neutrons or too many protons will cause problem. Second, the attractive force between the nucleus must be very strong to overcome the electrostatic repulsion between proton. Then we have to also, you don't need to worry about that, I'm saying, higher binding energy between nucleons. we can easily identify the stable nucleus by looking at some magic numbers. So I'm gonna give you a magic numbers which are either your protons or neutrons has one of these numbers, they will be highly stable. The numbers are 2, 8, 20, 28, 50, 82 and 126. If you have these many protons or these many neutrons, those atoms will be highly stable. Okay. Also, we can also look at the ratio, also the numbers. If both of them are odd numbers, protons and neutrons are odd numbers, they will be least stable. Okay. If protons are odd, neutrons are even, there will be little bit more stable. There are 15 elements, atoms are stable like that. Or if the opposite, even or odd, they also have the same stability, but a little bit more than the first one. But both are even, those are coming in our magic numbers, right? So almost 168 elements, sorry, not elements, 168 isotopes are there which has that unique number which causes stability. Okay, so let's see. Let's see some example based on even odd rule. Okay, even odd rule represented above, predict which one you expect to be radioactive. That means which one is unstable. Okay, so this is oxygen 816, oxygen 817. Okay, look at the protons and neutrons in this. Protons 8, neutrons 8. This one is proton 8, 17 minus 8, that will be 9. So this is has odd and even, this will be both are even. So that is more stable, this is unstable. That means it is radioactive. Second one, chlorine 1735, 1736. So protons are first one, proton 17 and neutrons 18, right? And second one, protons again 17 and neutrons are 19. So both are odd, so this will be the unstable one. Then neon has atomic number 10, right? Okay, so it is proton 10, neutron 10. Second one, proton 10, neutron 7. So this is the unstable one, that is radioactive. Then calcium, calcium is 20, 40. So 20, 40, so 20 proton and 20 neutrons. This one has 20 and 25. So this is the unstable. So all of these are unstable. That means they are radioactive. Okay, now we are going to discuss the biggest topic, which is very much advanced, but we can just look at the basic things in that, which is called the band of stability. So band of stability, when you draw a graph, here, atomic number here or number of protons here and number of neutrons here. Okay, you can see till atomic number 20 the line is very linear, then it is kind of going like this. If the n by p ratio lies on this line, they are stable. Okay, let's go see that. So attractive force in nucleus, we said there is the nucleons will have a strongest nuclear force. Nucleons means protons and neutrons will have strong attractive force, which is binding energy holds the nucleus. Then there is repulsive force, which is the electrostatic repulsive force. Electrostatic repulsion between positively charged protons. So whenever we look at the periodic table, we can see everything above 83 are radioactive. The reason you can see because of higher proton-proton repulsion or heavier nucleus causes less attractive force. So we know that neutrons are the mediators between the protons. So when their numbers are not in a ratio, that will cause the instability. Okay. So what is the role of neutron? We already discussed while learning atomic structure. We said neutrons are the mediators, right? To restrict the fight between protons. Neutrons will minimize the repulsion between the positively charged protons. Okay, so here there is a band of stability is given here. Now to read the value is little difficult for you, but I can say if the n by p ratio
through the process of beta
sorry. Okay, so if this is the band of stability, if higher n by p value or lower, below or above, okay, so this side it will emit beta particle when the atomic number is 83. I can't, okay, that is here, okay, emit beta particle. This will emit positrons to keep the ratio in that width. Okay, elements above 83 emits alpha particle, or I will say all kind of radiation to occur a stable ratio. So we can generally say, you don't need to memorize, it's a rough value and it is not accurate. If it is 1 to 20 atomic number, okay, atomic number 1 to 20, n by p ratio is 1, that is stable. That's what you can see here. Okay, till 20, it's a straight line. But if it is 20 to 40, if the N by P stable N by P ratio is 1.25. If it is 40 to 60, N by P is above 1.25 to 1.50. Let's say it is between 1.25 to 1.50. We can say 1.30, something like that. Okay. So like that, you can like a kind of predict the type of stability looking at the N by P ratios, and there are practices which this one you need to know the N by P ratio to answer the question. This one you can generally answer based on that. Okay. I'll do 2 questions, then after that you are going to finish and check the answers key in class. Okay. Give me 1 second. Okay. First question. If unstable, determine the type of decay of magnesium 20 will undergo and write the decay equation. Okay. So magnesium 20, we know the mass number, atomic number is 12. So protons will be 12. Neutrons will be 20 minus 12 will be what? 8. So when you take the N by P ratio, okay, so that is 8 divided by 12, the value is 0.67. The atomic number is 1 to 20. We said if it is 1 to 20, N by P must be equal to 1. So N by P must be equal to 1, but this is below 1. So if it is below 1, we said it will emit what? Positron. So it will emit positrons. Okay. Next one is francium 223. That's very easy, I would say, to predict the type of radiation, because I would say you don't need to calculate the N by P ratio, because if it is above 83, atomic number above 83, it will basically emit alpha particles. So it will emit 2 helium alpha particles and convert into a statin, and still it is unstable. Then it will continue that until it will go again another alpha emission until it become stable. Okay, so next one, this is barium atomic number 134 and mass number is 56. That is coming in this range, so it must be between 1.30 to 1.50. Protons are 56, neutrons are 78. Then take the ratio and you will get value which is 1.39. And we said anything above, let me correct that clearly, right? So anything above 1.26 or 1.30 is, that is what? That is in stable range, because it needs to be comes in 1.26 to 1.0, and that values comes in that range, so it will not undergo any decay, so that is stable. Okay, let's do one more. So technetium, which is 98, and 43, that is below, it is below below 83, so we have to check. So protons are 43, neutrons are 55. We'll take the n by p ratio. N by p ratio is 1.28. Okay, so we said 1 to 20 to 40, it needs to be in 1.25 ratio. Okay, so it is above that. If it is above, it needs to be 1.25. It's above that, so it will emit what? It will emit, which side? If it is above, it will emit what particle? Beta particle. It will emit beta particle. Okay, so finish the rest. So this is the normal, you can say uranium 238, uranium 238, 92. It is emitting alpha particles, so it will be 2 helium that plus, then you will get 90 and 234. Look at the periodic table and write the product element and complete that. Okay, so